Hey everyone! So continuing the idea of gradient, we're going to talk about the different linear lines, alright? So is it y equals to k or y equals to mx plus c, alright? We've already looked at the previous video and we know that, well, y equals to x has a gradient of 1, alright? So I'm going to use grad as the short form. So let's look at the other graphs. So let's look at y equals to 2x plus 1, alright? So pull out my ruler. So at x equals to 0, we have y equals to 1. Okay. At x equals to minus 1, I have y equals to minus 1. Okay, I can't do that, so let's change it. X equals to minus 3, y would be minus 5. Okay, so here we go. Much better. Now I'm going to draw the graph. Right. Label my axis. Well, here is y, here is x, and then here is 0, origin. Now, again, because it's a linear graph, it has constant gradient. So we can just pick any 2 points that we like. So I pick the point here. So we have minus 3, minus 5. We here have 0 and 1. Applying the formula, or just basically the change of y over the change of x, because the definition of gradient is change of y per unit x. Alright, so y2 minus y1, so we have y2 being 1, y1 being negative 5, so minus 5. x2 is 0, so I leave it as 0, and I have minus 3, which is simply 3. So we have 6 over 3 equals to 2. And the gradient of y equals to 2x plus 1 is simply 2. Now let's look at another graph. Let's say we have the green graph of y equals to minus x. Well, let's leave it as minus x. It's pretty simple. So minus x, well, we know it's going to be the other way around, right? So it's going to go downward sloping instead. So we have minus 2 at 2, and then, well, pass through the origin. So I have 5 minus 5. So I'm going to draw that graph down there. So this y equals to minus x. I'm going to label the blue graph later on. So same thing, because it's a linear line. It's a straight line, straight diagonal line. So we just need to pick any 2 points. We know that a point exists at 0, because at x equals 0, y equals 0. And we know that a point exists at here, right? So at x equals to minus 3, y will be minus 3, so 3. Calculating the gradient, we know that the change in y is simply 3 to 0. The change in x is minus 3 to 0. And the gradient is minus 1. Right, so we have the gradient of y equals to minus x is minus 1. Now we're going to look at the final graph. Let's say we have y equals to 5 graph. Right, so it's going to be a horizontal line at y equals to 5. So at y equals to 5 is basically this graph here. Okay, fantastic. And let's pick up 2 points again. So we know that a point exists at 0, 5. Another point exists at 5, 5. And the rate of change of y is simply from 5 to 5, so it's 0. Then the rate of change of x is from 0 to 5, so 5 minus 0. But you notice that it doesn't matter what the rate of change of x is, it's the numerator is 0. Right, so we know the gradient of y equals to minus 5 equals to 0. And you start to see a pattern, really. What do you notice? If you look at y equals to x, the gradient equals to 1. Alright, now I'm going to write this down. So you notice that in front of x, there's a value 1. You notice that for y equals to 2x, the number in front of x is 2, and the gradient is also 2. You notice that for y equals to minus x, the gradient is minus 1. The number in front of x is minus 1. And you notice for y equals to 5, the number in front of x is 0, because there's no x at all. And you notice that the gradient is also 0. It's a pattern, right? And what you notice is basically the number in front of x would be the gradient of the graph. And hence we have this result where if we have the graph of y equals to mx plus c, m is the gradient, right? The value in front of x aka the coefficient of x, would be the gradient of the linear line of the graph. All right, so that is the relationship between the linear line and the gradient. All right, so a fairly simple idea. We'll now carry on to other interesting graphs.